Hi, this is another in the series of Learning SQL on PostgreSQL, and this one is going to be about subqueries. I also want to apologize for the long gap between videos, but I've been caught up in a lot of different things lately, and I will hope to record a few things here fairly quickly. Um, so let's look at these. Let's do this is on chapter 5 from that book on subqueries. The goals are going to be, let's run this, to use subqueries in a where clause. And subqueries are basically a query inside of another query. They are confusing to some people, but they are extremely useful once you get the hang of them. And you can do them in every part of a query. You can do them in the where clause, which is what we'll start with. You can do them in the select clause, which is really valuable when you're trying to aggregate complex information and you need totals as well as subtotals. Uh, Things that are not grouped by as well as things that are grouped by. And you can use them in the from clause. And if they're in the from clause, they're one of the common ways to do them is to build a common table expression. And I will talk about a correlated subquery. So that's a lot to cover in this, but we'll do it step by step. So a couple of things about subqueries. Subqueries are queries within another query, as I've said. Even though they are contained within another query, they operate as independent queries. Subqueries can be used anywhere in a query, in the where clause, all this I sort of said, and they're always marked off by a parenthesis. So we're going to start with subqueries in the where clause. All right, so let's look at some subqueries in the where clause. Again, I am using Community Assist database, and I have the query tool running. I have pre-typed them so you don't have to watch me type everything for this section. And we'll look at a couple of different things. The first thing we'll do is look at subqueries with a max and a min. They could work with other things too, but this is where it's really useful. Let's look at a regular. We just want to get the maximum donation amount. So if I run that, I get that there's 10,000 as a maximum donation amount. If I want to see the person that does that using a regular join, what would happen is that I have to group by person key and person last name. So what I end up with is every person's maximum donation. That isn't very useful. I mean, you could sort it and probably find the information that you want. But what you can do, which is more useful, is you can use a subquery. So in this one, I'm going to do a join because I just want their names. Person first name, person last name. They're going to get the donation key, the donation amount, and the donation day. I'm going to go from person and donation. I'm doing the using join just because it's faster, briefer. And then I do where donation amount equals, okay, and then it equals the select max donation amount from donation. This is our subquery. Notice it starts and ends with a parentheses. It has the max donation amount in there. So whoever's donation amount equals the maximum will be returned. Couple of other things. This cannot return more than one value. When you're using the equal sign, it has to return a single value. So I'm going to do this, and we'll see that Scott Little donated the 10,000, and he did it on November 3rd, 2021. All right. So that's doing it in the where clause. But there's a couple other things you can do. If you need to return more than one value, you can use the keyword in. So this is a query that returns what people, their name and last name, are employees. So where the person key is in the person key from employee. This again is our subquery. It begins and ends with a parentheses. It's very important that we're searching for person key here and person key there. They have to match. They have to be like to like. All right. So when I do that, I see the names of all my employees. You can also chain all these things together so that if you wanted to go through multiple tables, like doing multiple joins, a couple of things that I would say is that a join is probably a better way to do this, but I want to show you how to do it as subqueries. And one big disadvantage the subqueries have is that you can only return the values from the first or the outer query, not from any of the subqueries. So I can return person key, person last name, person first name, but I can't return their employee key, their position name, or any of that. But we're looking for all the people that are volunteers. So we do select person key, person last name, person first name from person, where the person key is in employee, where the employee key, again matching like to like, is in employee position, where the position key is in position key for job position, and where that position name equals volunteer. Again, this could be done as a join and might be better as a join, but we find that Carly Master is the volunteer. All right, but it's doable as that. One last thing I want to show you is this is actually easier than an outer join. But if you use not within, you can have the same effect as an outer join. You can find all the things that are not included in a table. So I'm doing the same thing that we did with an outer join. I'm looking for what grants have never been applied for. So select grant type name, grant type, where grant key, type key is not in the list of grant type keys from grant application. And when I run that, you'll see that I get travel and funeral have never been asked for. So now we'll talk about subqueries in the select clause. So this is basically in the list of fields, right, that you have. You can have a subquery that will return a field value. Subqueries can be used in the select clause as well as in the where. A subquery in the select can be used to bring in aggregate values that are not subject to the group by of the outer query. The subquery will define a single column and it must return no more than one value. If there's even the possibility of the query returning more than one value, the SQL will throw an error. So let's look at the subquery that I prepared. Excuse me. I will be going through it in pieces. The first part doesn't have a subquery at all. It's just a join. So I'm going to get the year, I'm going to get the grant type name, and I'm going to get the total amount that was asked for. And to make this a little bit simpler than it could be, I'm going to limit it to the year 2021. I'm joining a grant application with grant type, so I can have the grant type name. Again, I'm extracting the year, which means I have to group by it, and then I'm going to group by or order by grant type name. So there you have it. We have all the different types and the totals for that year for those types. All right, so then we'll add a subquery. And the subquery will be added as a column in the select. It is going to ask for the sum from the grant application where the year is 2020, again 2021. Again, it has to ask for a single value. Notice that it's a complete query and that it begins and ends with a parentheses. It has to have its own from. It has its own where here. All right, and what it'll do is it will return a single value that is not grouped by the grant type name. So we're going to call this as a subtotal. The last one we called a subtotal. All right, so I am going to, I called it a total last time, but it should have been a subtotal. So this time it's a subtotal. let's do this. And we'll see that our subtotal is the same as the totals from last time. But our new total is the same all the way down because it's the total value for the whole year. There were $12,000 requested in the year. So 12,350 and 74. Now it repeats all the way down because it is just one value. It is the total of all of these. If you were to add all of these up, they would add up to this. All right, so then we're going to do one other thing with this is we're going to get a percentage. What percent is each one of these of that grand total? So we have this same thing, select year and grant type, and then the sum, and then we have the other subquery that we did right here, and we call it total. And then we're going to add an equation, the sum of the grant type, grant application amount. That is the same as this one, and it will be subject to the group by down below. So it will be grouped by grant type name. And then we're going to divide it by our subquery that we had up above. Select the sum grant type grant application amount from grant where the year is 2021. This one is not subject to the group by because it's a whole independent query, and it will basically give us that total. You get a percentage by dividing the part by the whole. So we'll divide the subtotal by the total. And I also multiplied it by 100 to give it a percentile. And I called it type percent. All right, so that's a lot. This is a complicated looking query. But if you think about it in its pieces, it's not so bad. Let me run the whole thing. Now, a couple of things that I would do is I would format this so that these were prettier, particularly the percent. You could use a string format or whatever, and you could also format these as money if you want, using the character format things that we did a long time ago in another video. But I'm going to leave that to you. Instead, I'm going to walk through this one more time very slowly. The first thing is a fairly complex query in and of itself, but it has no subqueries. It's basically extracts the year from year and the grant type name and the total. And it joins two tables, grant application and grant type. And we limit it to the year 2021 because just for ease, it would be a little more complex to do this with multiple years, though doable. You could do it by multiple years. We'll group by the extract because we have to, and by the grant type name. And I ordered it by grant type name just to make it a little bit easier. The second is exactly the same except that we've added a grand total basically as a subquery. It starts and ends with parentheses. It gets the sum of the application amount from grant type where the year is 2021, but it doesn't, it's a totally independent query. It is not reliant on the group by like the outer query. So it can return the total of the whole year, which it does, 12,350 and 74 cents. The next thing is the same except that it's even more complex. We've added another field, but it's a result of a calculation. We're getting the sum of the grant application amount. This is just the sum. It is still part of the main query, so it's exactly the same as this, and it is subject to the group by grant type. And we have the subquery that we wrote up above, which is not subject. Totally independent query will return the grand total. And we multiply by 100 to give it a percentage, make it a percentage. That's what percentage means, is per 100. And we do all of that together. And it could get even more complex, but this is only doable. This kind of thing is only doable with subqueries. It makes for, you can do really complex setups this way and get a really good summary of what's going on in your data. All right, so that's it for the subqueries in the select clause. Hi, so now we'll look at subqueries in the from clause. So a subquery in the from clause is basically the effect of a query, query, and a query. The subquery takes the place of a table or a view in the from clause. Subqueries in the from clause are excellent for prearranging data or the pre-aggregation of data so that the outer query can be simpler to compose. There are two formats in the from clause. There's table or derived expressions and common table expressions. They do the same thing. I will say that common table expressions are generally preferable, and I'll show you those in a moment. So actually I'm going to escape this and bring up this. So subqueries in the from clause, as I said, derived expressions are the most direct form. So here we have a query. Select first name, last name, donate, date, and amount from, and then we have our subquery, which just like all the others has a parentheses to begin it and a parentheses to end it. Notice that I alias person first name as first name, person last name as last name, donation date as I left, I think that the same, donation amount as amount from person, and I used an inner join with person key. I have to alias the subquery because it needs to have a name to be processed as a table. So basically we are querying a query. We are querying this other query. And it is important that the fields in the outer query match the aliases or the field names in the inner query. So let's run this. This is basically, we're looking to see information about people that have donated. Okay, so we see their first name, last name, the donation date, and the amount. So that's a query with the subquery in the from clause, where you basically do a lot of the work of the query in the from clause. If you save these, later I'll show you how to make temporary tables. They can be really useful because then it's simple to do the outer query. All right, so I'm going to do another one. This one is a little bit more complex. I want to see all the people who have applied for the grant type of rent. So you have last name, first name, date, type name, and amount. Date is in quotes because it's a reserved word. From, and then our subquery begins and it ends here. So select person first name, person last name, last name. So again, first name becomes first name up here, last name becomes last name up here. Grant type name becomes type name, and the amount, grant application date becomes date, grant application amount becomes amount. From person, and then we do our joins in the subquery. Inner join grant application using person key and inner join grant type using grant type key. Again, we have to alias it as application. And I did a where clause, which is in the outer query where the type name equals rent. And I did it on the outside because it's easier to change that here if you want to, change it to a different type of grant. So anyway, when we run that, we will see that these are all the people that have applied for rent and what their request amounts were. All right, so let's talk about table expressions, which will do exactly the same thing, but they're structured in a different way, and they're structured in a more logical way. Basically, you do the alias first with donation info as. You have your beginning and ending parentheses. I separated them out like this. They don't have to be. We have the inner query, which is essentially the same as the other inner query that we did. And then after we have defined what that query or that table is going to be, then we do our outer select clause. Select first name, last name, donation date, amount from donation info. In the query, the derived expression, you didn't know what these would be beforehand. You had to make sure that they match. Here you know what the field names are before you do your outer query. And it's easier. You don't have to worry as much about making them match. There's a helicopter outside. I don't know if you can hear that. All right, so that worked and gave us exactly the same thing. Here's the other one as a table expression with application as. Again, we're aliasing it, and as defines what it's going to be. We have the same query that we did for the subquery before. Person name, person last name, application date, grant type name, and grant application amount with the same aliases. From person, the inner join with grant application and grant type. And down here I did select first name, last name, date, type name, amount from application. Where type name, this time I changed it to food. That's how all I have to do to make a different request. So let me get up where I can quote, highlight the whole thing, and let's run that. And you can see that it is all the people that requested food and the amounts. So this is a table structure, a table query, and it's a little bit more structured. It's a better way to do it. It starts with the keyword with, the alias for it, and then the word as, parentheses, parentheses, the subquery, and then the outer query. All right. So just real quickly, table derived expressions and table expressions. Table expressions are more structured and are probably better. All right, we'll go on to the last thing now. The last thing we're going to talk about is a correlated subquery. This is the kind of thing that might show up on a interview test for a database person. A correlated subquery is a lot like a recursive function in programming. A recursive function is a function that calls itself. A correlated subquery is the SQL equivalent of that. In a correlated subquery, the subquery references the outer query. And this can be useful in certain situations where it's important to make sure that the outer query and the inner query are referencing the same values. To create a correlated subquery, it is necessary to alias the table with different aliases in the outer and the subquery. And this is so the table can be joined as if it's two different tables. So, let's look at an example of that. Okay, so we go back to here. Now, there's a couple of things. We have a query. Select grant application key, grant type key, grant application amount from grant application, and then I alias it as G1. It could be called anything that you want. Where the grant application is greater than, and then what we're doing for the subquery is select the average grant amount from grant application G2, so we alias the table again, where G1 grant type key equals G2 grant type key, order by grant type key. So the whole point of doing this is so that you compare like to like, apples to apples, and oranges to oranges. If you didn't do this, then it would try to compare everything to everything. Rent is going to have a very different kind of average than food, which is going to have a very different kind of average than childcare or medical. You don't want to compare the average of rent to the average of food, the average of medical to the average of childcare. You want to compare like to like, food to food, rent to rent, right? And we're looking for where it's bigger than the average amount. So I'm going to run that. And we'll look and we'll see that it has the grant type key. We'll do 2 because there's 1, 2, 3, 4 twos. And our values are like 600, 800, 1300, and 800. So these are supposedly are all greater than the average. To confirm that, let's look at the average. The average is 583. So if we run this again, we can see that all of these are greater than 583. The same thing could happen if we wanted to look at just grant 3. Grant type 3. All right, the average is 393. And if we look at this, we can see that each of these is greater than 303. One of the reasons you might do this is you might want to see which grants seem to be asking for an excessive amount. This is the amount that they're asking for. It's not the amount that was given. All right, so this is a correlated subquery. Once again, there is a outer query, and then you label the table. Grant application, so I called it G1, grant 1. Where grant application amount is greater than, and you could use other operators there, but select average grant application amount from grant application, and then we have aliased that table, the same table, grant application, but this time it's labeled G2, where G1 is equal to G2, and this is also where the inner query is referencing the outer query, where G1 is equal to G2, the grant type key. So the inner query is referencing the outer query. All right, and then we order it by. Okay, I think that's it for subqueries. It's just a complicated topic, and I hope this helps some.